Okay, students, today we are going to discuss about the Modi's method here. Okay, this we say it is a optimal method. Okay, so in the previous case we have studied so many. Take for example the uh, we have studied much on that. Am I correct? Take for example we have studied penalty method, and we have already studied Fogel's approximation method or penalty method, least cost method, and northwest corner rule, like that. But in this particular class we are going to study what is called the Modi's method. This Modi method is a very important method because it gives the optimum solution for us. Optimum means what? The transportation cost would be minimum among minimum, and that is what the least minimum transportation cost this particular method will give. Okay, therefore this particular method we say an optimum method. So there is some algorithms or the way that we have to do, or the steps on which we have to do this Modi's method. The first step is that we have to find the initial basic solution by least cost method or northwest corner rule or VAM method. Then afterwards we have to find the fixed cost for each basic cells. For basic cells means the cells, allotted cells. Okay, the number of items we are allotting to go one place to the other. That particular cell is called uh, basic cells. For that we have to find so-called fixed cost. Fixed cost means Cij equals Ui plus Vj. Okay, right. So we have next step number 3. We have to find Ui and Vj's by setting u1 is equal to 0. It is possible. Okay, if you take the initial value u1 is equal to 0, then we can find out all ui's and vj's for the cij's. Okay, that is what step number 3. Now step number 4, of course, to calculate net values for non-basic cells. So after finding this fixed cost for basic cells, our aim is to find out the net values for the non-basic cells. Non-basic cells are cells where the number of transportation items, that is Xij, are not assigned. Those cells are called non-basic cells. For that, net values we have to calculate by using this particular formula. Ij equals ui plus vj minus Cij. Ij equals ui plus vj minus Cij. So net values for non-basic cells we have to find out. Then step number 5, the all net values are 0 or negative. Okay, if all the net values are 0 or negative, then our optimum is reached. Our optimum is reached when net values are 0 or negative. Okay, so if net values are not all negative or 0, then the optimum is not reached. We have to go to the next step. So very important step. In the 5th step, we have to see all the net values. If all the net values are 0 or positive, then it is optimum is reached. If not, that is any one of them are positive, then optimum is not reached. So for that we have to go to the step number 6. Now we have to form a loop starting from maximum positive net values. In the step number 4, we are calculating net values. So all those net values we have to we have to give importance. So from that point we have to draw um, uh, we have to form a loop starting from the maximum positive net values. Okay, so to draw a loop, a lot of conditions are there. We have to draw a straight line only. We should not cross the cells. Where it start we have to end. It has to go only anti-clockwise or clockwise, like that. To draw the loop we have a lot of rules and regulations. Then we have to assign theta and minus theta for the corner points of the loop. we have to assign theta and minus theta for the corner points of the loop, starting from the starting cells. Theta minus theta, theta minus theta for corner cells we have to assign. Okay, that is step number 7. What about step number 8? Step number 8 is that we have to assign the theta such that minimum equals minus theta assigned the basic cells. That's what we have to. We have to assign the uh, minimum among minus assigned theta cells. What is that? Minimum among minus theta assigned cells that we have to take as theta. Okay, right. Now we have to rearrange the basic cell values using theta values. We have to rearrange the basic cells values using theta values. Okay, because the theta will take some value. If you substitute those values in those theta minus theta, the assigned value will be changing, and that's we have to note that. And next, what is the step? We have to continue from the step 5 onwards till all the net values are positive. All the net values are 0 or negative. 0 or negative. Since the step number 5 is what? To calculate the fixed cost for the basic cells. So afterwards we have to come again, then net values, then from the net values we have to draw the loops. After drawing the loops we have to assign the theta values, minimum among minus theta places, and then theta values we are assigning, then our assignment will change, a new structure will get, we have to do again until all net values are 0 and negative. If 0 or negative comes, then we achieved our goal that we have to stop because we have reached the minimum among minimum, that is optimum we have reached. Okay, then the allocated values xij gives the solution for the problem. The allocation values gives the solution for the problems xij, and the minimum is that would be equal to will be equal to the summation of the products of Cij and Xij, product of the transported values multiplied by the corresponding transportation cost per item, and that gives the optimal solution for our problem. Okay, so 11 steps are there in solving the transportation problem by Modi's method. So Modi's method is the optimum method. It may be asked in the examination 10 mark question. So with that, coming to the end of this session, and the next we will be taking the problem, and we will be calculating all these things. Okay, so keep in your mind, play this video again and again so that you understand well. So with that, I'm coming to the end of this class. Thank you.